Hello and welcome everybody to my talk in the visualization track at this year's notes. My talk is, as she said, creating your first graph visualization, a low-code approach. Please don't go away if you've already done your first graph visualization, as there will be lots of things that you will learn and enjoy in this session too, I'm sure. This presentation is both for software developers and for those who are not developing software themselves. I'm positive that all of you who want to learn more about graph visualization find takeaways from it. So I guess at this point, all of you know what graphs are and how powerful they can be. So I would like to show you how you can bring the power of the graph to your interactive applications with graph visualization, because actually most graphs want to be visualized. So quick introduction again to myself. Who am I to tell you about graph visualization? As she said, I've been working exclusively on graph visualization for the past almost 20 years now at yWorks. The tagline is the diagramming experts. And as a CTO, I've been the lead architect for yFiles, our family of graph visualization programming libraries. So please learn more about our product and our free Neo4j related visualization tools on our website. But enough about me and yWorks. So this is my agenda for this short session today. I'll briefly explain why you should consider using graph visualization, and I'll show you some of the many use cases for advanced graph visualization. The main part of my talk will be an interactive live demo of our free web-based rapid application development tool, the yFiles app generator. I will introduce you to the tool and we'll create a simple graph visualization application from a Neo4j database using low-code, almost no-code techniques. And after you know the basics, we will see how we can create truly useful and awesome graph apps using some more advanced visualization techniques. Okay, so first some background on graph visualization use cases. As you know, much of today's data is not created manually, but it's collected automatically or aggregated from many sources. And so for most of these sources, being able to visualize relations and dependencies is not only helpful, but actually crucial for their understanding. So graph visualization is all about the relationships between entities and their properties. So if your data has many of them, visualization is super useful. Visualization is not only for developers and scientists. With visualization, experts can verify their understanding of the data and systems, for example, to document and test database relationships or queries or perform data analysis and so on. However, visualization is and should not just be for the techies, because end users also frequently need to work with complex connected data. For a large fraction of connected data sources, a graphical user interface to the data is a requirement for end users to be able to efficiently work with it. There are many use cases where bespoke visualization applications help or enable end users to work with complex data sets. And with the ever-growing complexity and size of the data that we're dealing with, there are more use cases popping up every day. Visualization helps users with finding answers to the questions they have. With Neo4j, we have a very powerful graph database, and you can store all kinds of data in it, as we've seen today. Much of it can benefit a lot from good visualizations. In the past, we found that often people aren't even aware of the possibilities graph visualization offers. So let me give you some ideas. First, here's a quick overview of some domains where graph visualization is absolutely crucial. These are all use cases that we know our yFiles customers are already covering, but there's certainly more. In fact, often the reasons for why you're using a graph database instead of a relational database to store your data are similar to why you should be visualizing it in order to truly understand it. It's the connections. Here I tried to partition the various use cases into high-level, non-domain specific use cases for graph visualization. The apps you see in the screens have all been built with our libraries. You can find them online in our demo showcase to play with. So what are people using graph visualization for? They want to do exploration, like for example in fraud detection. They want to do data mining, like in process mining or maybe supply chain visualizations. They want to organize things like in organizational charts, or maybe to analyze and depict relationships between companies or institutions. For mapping, very obvious is disease mapping or maybe crime mapping. Monitoring, like in network monitoring, you can monitor both social and physical networks. And also modeling, of course, like in BPMN and UML and similar charts. but it's also used for planning, like in network or database infrastructure planning. And that's still not exhaustive list, of course. I bet most of you recognized one or more of these use cases, or even already got some ideas for data that you maybe already have and now want to visualize. So let's see how you can create a custom visualization using the data stored in your very own Neo4j instances. Let me introduce to you the yFiles app generator. It's a free tool that anyone can use with their desktop computers in a web browser. There's no sign up or registration required, while it's ultimately meant to be used with our diagramming software libraries, you can make good use of it without the libraries as well. So let me show you the tool. So that's the tool. I just went to our website and entered the URL. And once you open the app, it will greet you with this welcome screen. And you can watch this introductory video to learn more about the app. And there's also example projects that you can take a look at. And we also have the movies database that we just saw. And I'm also going to take the movies database as an example here. But I prepared a much simpler version of it so that we can walk you through this. So that's the minimal example that we need to create an application that shows a Neo4j graph. So what we see here is an ETL pipeline. So this is an extract, transform, and load pipeline. This is not the graph that your end users will see. We're using the power of the graph to describe the way that we configure the application and the way that we load the data from our data sources into a visualization. So we have the Neo4j loader over here depicting the source of the data, and this is the resulting graph that our end users will be seeing. And when I press the play button, I get to see a preview of the application that I'm creating. So let's take a closer look at this. The Neo4j loader node over here, I configured it so that it knows about the credentials so that it can connect to a Neo4j database. So it has the usernames, password, and so on. And of course, it also has a query. And in this case, I'm querying the persons who directed a movie, and I'm returning that query and limiting it to just 10 elements. Once this application runs, the functionality behind that node will directly connect to the database via the Bolt protocol and issue the Cypher query. And once the Cypher query returns, I get the data in form of objects that I can introspect. And the node splits them up into nodes and relations. And I can take a look at those results. So there's a movie node, and it has some properties like a title, a tagline, and so on. I can see this is all the value that gets returned by the query. Now this part actually takes some data as an input and creates a diagram out of it. So we have two parts. We want nodes and edges in our diagram. And for the most simple use case, we are simply taking the relationships and the nodes from the Neo4j loader and passing them through those sources to create a graph. Now, how does that work? Relations have properties like start and end, which are pointers to nodes, basically. And those nodes also have an ID to which those pointers, those references resolve. And I need to declare to the engine that it should be using the start ID and the end ID to reference into the ID property of the nodes. And out of this information, it will create the graph for the visualization. As there's no geometry information in the graph, we need to run a layout, meaning we need to arrange the elements on the screen to create a useful visualization. Like we just heard about the force-directed layout. This is such a simple layout over here. And if we do that, we get to see the graph. But as you see, there's not much to see there yet because we don't have any labels. So as a next step, I prepared two configuration nodes over here that will add labels and shapes. With the creator node, I can specify the color and the shape and so on, and bind that to the values in the data. For example, I'm declaring that I want to see the title of the movies, which is part of the property subproperty in the elements, as a label in the graph. And when I run this, I now get to see the graph as we would have expected it. So there's the movies over there and some persons in this case, it's the directors who directed the movies. Now that's also already it. You can now go and save that project and share it with your friends, or share the link with it, and they can just click it and they will also be able to see that. But the real power of this application comes when I use this button here below. This will help me generate a source code bundle that I can download and then run in my own IDE. And it will be the application that I just configured. As a web developer, I get to choose between different frameworks that I would like to use, like React or Vue or Angular. And then I can choose which programming language I want to use, whether it's TypeScript or JavaScript. And I can add some default features out of the box, like I want it to be editable, I want to see a context menu, I want tooltips, and I want it to print, and I want to search it, and an overview. And once I'm done, I just hit the download button, and it will create that zip file for me that contains the sources for this application. If we look at this, that's a simple web application that contains a package JSON which declares all the dependencies that it has. And once I unzip this, open them in my IDE and install the dependencies, I can launch the application. This would take a few seconds, so I prepared that. So this is it looks like. And when I launch the application, it will go again, fetch the data from the database live, and will present me with the results that we just saw in the app generator. Now, for example, I can use this functionality to search for a certain movie and then highlight it, and I can edit around and play and export it and so on. And all this without writing any line of code, all with the app generator. So far, to many of you, this probably doesn't look very revolutionary, I guess. At least if you have seen some kind of graph visualization before, which you have today, it probably looked very similar to this simple visualization that I just had. Now I'm going to show you that it's actually not that difficult, even with low-code techniques, to get much more exciting results with more engaging graph visualizations. Let's see how we can get more out of graph visualization. I'll be covering these 5 different aspects now. Loading and transforming. That is, changing the way we map the information in our graph database to elements in the diagram. Styling, which is about rendering more detailed information directly in the diagram so that it's easier to see for the end user. Automatic layout, which can help us to encode information right into the arrangement of the elements in the diagram. And also graph analysis. It can help us to leverage we can leverage graph analysis functionality to improve both the layout, the styling, and make the interaction smoother. And finally, user interaction, to get more than just a static diagram, no more than just a nice picture. Note that the following are just examples, and they may not always make perfect sense in the context of the movie database that I'm using here. And it really depends on the use case and the questions end users have when working with visualization. You should always consider the user experience of the resulting graph visualization app and ask yourself, what information do users want to or need to see? What questions do they need answers for? And what are the most frequent and important user stories? So let's create something awesome. Back to the demo, the application. And the schema of the graph is not always as simple as it is in this case, where we have just movies and persons. And there's actually more information in this graph too. So we have, as I've shown you, there's properties in the nodes that we can leverage, and we can use that to change the way we visualize the graph. For example, we have this release date, which is the year when the movie was released. And what I'm going to do now is I would like to add new nodes to the diagram which represent the decade in which a movie was rendered. So I'm taking the output of the nodes again and filtering for those which are just movie nodes. And then I'm calculating the decade by dividing and multiplying by 10 and adding this as an additional data to the objects. And this doesn't happen in the database. This happens just in the client, in the visualization, in memory, on the fly. So we're not changing our database, never even touching it other than reading it. So we added this additional property decade, and because we still have all the nodes and some of those are duplicates, we're making sure that we only get to see different decades. So we were left with 3 different decades, 1990s, 2000s, and 1980s. And we pipe these into another set of nodes, which we want to add to our visualization. Once I add this to the graph builder, you see that over here, the new decade nodes appeared. So this isn't useful yet because we don't see the connections anymore. So why not add new edges between the movies and the decades they were released in? So for this, I'm going to take the movie nodes again, and this time using that information to draw a connection between the movie and the decade node. So I'm using an edge source here, telling it to connect the movie itself to the decade node. So this will produce edges between the movies and the decades, and that's the resulting visualization. So we now see that the Matrix and Devil's Advocate have all been released in the 1990s. And none of this required us to change the database, nor even to change the query. We're still using the same Cypher query from the beginning. But adding new edges to visualization is not always a good idea because it makes it more crowded. What else can we do? Again, in this example, I'm filtering for the movie nodes and adding the decades. So we get to see those decade nodes. But this time, rather than connecting the movies to the decade nodes with an additional edge, I'm going to declare that I want them to be put into the corresponding decade node as a group node. So they will be contained in a larger node. And for this, I'm going to change the function that declares what the parent group node is for a certain movie node. And that's a few lines of code, but it's very simple. If the item is labeled as a movie, I'm going to use the decade node as the parent node. And otherwise, I'm not going to use a parent node. And with this applied, I get this nice visualization where I can see for each decade, there's a group of nodes, and all of the movies that have been released in the same decade are neatly arranged next to each other with this visualization. But it's not only about nodes, it's also about edges. Why not add more edges to the visualization? For example, in the movies database, there's this information basically telling you which actor acted or co-acted with someone else in the same movie. That information isn't only implicitly stored in the database. So we have relationships between persons and movies. And when 2 persons both acted in the same movie, they form a triple basically, which we return over here. So this query produces triples. And while technically these are all nodes, actors and movies, we now interpret them as edges. Well, not all. Of course, we're also using nodes, and we are projecting the actors, actor 1 and actor 2, into a node source so that we see all the actors because we want to see the actors. But now we are using that same data to create edges in our visualization. We're telling it to use the identity of the second actor as the target node of an edge, which starts at the first actor. And when I add this to the visualization, I get to see this visualization where we can see all of the different actors in my query and connected by a relationship, by an edge, when they were co-acting in a certain movie. I also added the label for this movie. And now you see, for example, that many of those over here co-acted in all 3 of the Matrix trilogy movies, except for Emil. Yeah. Okay, but still it's not really beautiful. Let's take a look at styling. Let's add more information to the nodes themselves. Nodes don't have to be just rectangular and black and contain some edges or maybe even colorful, some text labels. But we can add more information right to the visualization. As we've seen, for the movie nodes, we have this information where there is also the tagline. There's also the release date that we've been using. Sometimes there's also the number of votes the movie received. And why not add this to the visualization? So I used this specific node creator, which only applies to the movies, and the other one only applies to the actors. And I asked my designer, can't you come up with a template with SVG with your designer tool, like for example, Adobe Illustrator, that looks like a nice visualization for a movie node? And they came back and gave me this. This is a part of an SVG snippet. And it had hard-coded names in there. And what I'm now doing is I'm using data binding to replace the hard-coded names with the data coming right from the database. So I'm using the title as well as the release date, and I'm also using the votes to show some star rating in my visualization. And the same for the actor nodes with the different properties. And if we look at the resulting graph, we now get a much nicer visualization. If we zoom out, we see those icons and we can immediately distinguish movies from actors. If we zoom closer in, you will see that more information appears. So this is multiple level of detail rendering. If you zoom in, you also get to see the release date, how many stars, how many votes the movie got, and the tagline, as well as, in this case, the birth date of the different actors. So this is done via data binding and with level of detail rendering. Makes it a lot more easy to understand, in my opinion. After styling and transforming the data, we can also apply more sophisticated layouts. yFiles comes with a huge range of different layouts. So we have hierarchic layouts. We have the force-directed ones that we saw in other talks already, but also orthogonal ones, very compact ones, and so on. They all can be configured and parameterized, and they have several options. And for some of them, like the hierarchic one, I can even use the information that's in the database to drive the visualization, to drive the layout. In this case, I'm going to virtually partition the grid where I'm rendering the graph into the canvas where I'm rendering the graph into a grid with columns and rows. And I can specify which column to put the elements in via a binding. So I'm checking whether the node is a movie, and if it is, again, I'm using the decade as an index into the column I want to put the node in. And for all other nodes, I'm going to put it into the first column. And once I apply this, I get this layout, which makes it super easy to see which movies have been, again, released in a certain decade. So these are the 80s movies, and these are the 90s and the 2000 movies. This time, not via additional edges or group nodes, but via a different arrangement. So much for automatic layout. We also have graph analytics. So as you know already, you can run analytics in the database, but you can also run analytics locally just for the purpose of visualization. So instead of piping the graph directly into the layout, I'll be now piping it through this analytics node. And this analytics node provides all the automatic, the graph analysis algorithms that we have in yFiles, which is also the various clustering and modularity and betweenness and so on algorithms. And once I calculate these values, I can use the results to for various purposes. For example, I could be using it to change values in the visualization or the layout or the interaction. In this case, I modified the template I was given. so that the value is rendered as this progress bar inside the node. So if I change the algorithm, you will see that we now get to see different values in here. That's how you can, for example, use analytics in your graph. Last but not least, interaction. So far, this has all been static, and even though it's nice to look at, there are some hard-coded decisions that I made that may not suit everybody. So an obvious choice for interactivity is to take the Cypher query and replace those hard-coded numbers that I had in there, like the limit or the year, which determined which movies I wanted to see depending on their release date. Why not make this as an input to the user, a custom input? So I can use this input as a parameter where I can determine the limit and the year that I want to use. And now with this user input node over here, I can enter the value that I want to use. And once I connect that, the graph visualization will use that value. And if I ran the application later on, it will also query those values for me. And if I submit them, I will get this visualization showing only the movies after the 1990s. So that's a very simple example for interaction, of course. So that's it already for the live demo part. I hope that by now you've seen that good visualization can really add a lot of value to an application, and it doesn't have to be that difficult to implement. You don't need to change your database or data source schema in order to create a custom visualization that helps your users understand and work more efficiently with the data. You can work with multiple data sources and derive additional information while loading the data. And with the yFiles app generator, you can scaffold really nice visualization apps using low-code techniques only. But of course, if you take a closer look at the demos that we provide on our website, you will see that even though the app generator can help you a lot with building your app, there's so much more functionality in our software library that you cannot yet, unfortunately, efficiently put together in a visual programming tool like the app generator. It is a wonderful tool to quickly create a proof of concept, sometimes even a minimum viable product. But sometimes it's just the starting point of your journey into graph visualization. Once you have exported your project as a source code bundle, you can add all the other functionality and combine the features that constitute to a truly great user experience. And this is what graph visualization should be all about. So get out there and create your own awesome graph visualization projects. But before you do, please ask your questions in the chat. I'm not able to answer them here right now, but in the panel discussion shortly after the next talk, I then will get the chance to respond to your questions. So see you in the panel discussion, and always happy diagramming with Neo4j and the yWorks tools and software libraries. Thank you so much.